All right, so hi everybody, my name is Jackie Quinn. I'm from Florida. I work for NASA at the John F. Kennedy Space Center, and I am an environmental engineer. I'm also a civil engineer. So I have a bachelor's degree. So my first 4 years in college, I went and got a civil engineering degree. I always liked working with water and the environment. So when I went back for my graduate degrees, I went to my master's and my doctorate are both in environmental engineering. Now, environmental engineering, like civil, has several paths that you can take, choose to focus in. And my path in environmental is in groundwater cleanup. So I did a lot of work in cleaning up contamination in groundwater when I first got my master's and my graduate degrees. But when I first came to NASA, I worked on the shuttle program. I worked environmental controls, life support systems. So basically keeping the shuttle rocket, and we're no longer flying the shuttle rocket, but we used to. And I worked on the fluid system, the thermal system, breathing air, and water systems for the shuttle. And then I went and did some more traditional civil engineering work, meaning I designed roads. I designed water retention systems, and I started doing environmental engineering investigation work. So trying to find if we had contamination in groundwater. So I did those for many years, and that's my emphasis in my graduate program is in environmental cleanup. And then I did that for over 20 years. And then, because I'm old, right? I've been at the agency. I worked for NASA for 33 years, so a long time. And so I started to work on the lunar program, going back, the Artemis mission, going back to the moon, about actually in 2007, so a long time ago. And my focus was on finding water on the moon. So that's where I have been investing my time for the past, I don't know, however many years that is, 15 years.
That's absolutely incredible. Do you mind if we just jump right into some student questions? Some have already been.
Go for it.
So some of the kids want to know, how did you initially get started in it, having an interest in environmental science?
Well, I think I always have wanted to be outside and outdoors and with nature. I have parents that are science educators, so they were science teachers. My mom taught high school science, and my dad really focused on how to get young kids engaged in science early, and he was at the college level. He taught science education, in fact. So my time as a kid was always spent outdoors. We didn't have these computers that you guys all got. I didn't sit like this in front of my phone all day long. I went outside and I looked for mushrooms and I looked for flowers and I, looked at the water and the bridges and went hiking and, was outside, right? And so I think my love of the outside really, when I, kind of led me to go into environmental engineering, I wanted to find a degree that allowed me to use my skills in math and science, right? Because I liked math and I liked science and I was good at it, right? And so I knew I needed to go into something along those lines. I originally thought I wanted to do veterinary medicine, but ended up going into engineering instead, and have had just an incredible diverse career. You heard me talk about doing shuttle engineering, to road design, to stormwater design, to environmental cleanup, and now developing a payload to go to the moon. So I mean, that's a pretty diverse set of activities for somebody to do with a civil and environmental engineering background.
That is all like interesting. I mean, you've kind of run the gamut where you do the environmental engineering and now you're looking for water on the moon, which is absolutely I can't imagine what a day in the life of your job is like. We have a question from Simon. Simon had a very good question. Simon, you should be able to unmute to ask your question. Go ahead.
Yes. What method do you use to try and find water on the moon?
So, hi, Simon. So we're using the method of an instrument detecting it as a gas. So we didn't actually think the water had moon on it. I mean, the water had moon. Listen, that's backwards. We didn't actually think the moon had water on it until L-Cross landed on the lunar surface in the 2009, I think was that mission. I'd have to go back and check the date. But so in 2009, we took a rocket and we let it land really hard into Cabeus crater on the south pole of the moon. And what happened is when it hit the dirt, the lunar dirt, it's got a special name. It's called regolith. But when it hit the lunar dirt, it threw up everything and it caused an ejecta, a cloud of dirt. And we had instruments traveling behind it that analyzed what that dirt was. And they were looking not just for solid particles, but they could measure gas particles. And what they found was they could measure water, and they could measure quite a bit of it, like 5% by mass. So if you took that into terms of how much water that is, and I think that the scientist of that mission, Dr. Tony Colapret, he sort of emphasize that it's like buckets full of water. It's like a lot of water, because you think about how big the moon is, and 5% by mass on the top part, on the south pole and the north pole. And we know that water is at these polar regions more so than anywhere else around the equator. And there's a reason for that. Those polar regions stay very cold. The sunlight, because of the tilt, how the earth has a tilt, the moon has a tilt, the tilt of the moon, it means that the sun rays come in at about a 3-degree angle off the horizon, meaning it just barely sort of grazes the surface. And so it doesn't get very hot in those areas or for very long because of that tilt. And so it's really cold in some of these craters. I don't know if you guys have learned about Kelvin. Kelvin is a measurement, like you've heard of degrees Fahrenheit, degrees Celsius, and degrees Kelvin. When it gets that cold, you measure in Kelvin. Some of these craters have about a 25 Kelvin temperature. And so the water exists in that region because it's frozen solid. And even in the vacuum that is about the moon, it can't escape because it's frozen and it's solid and it's stuck in that dirt, that lunar dirt. So when L-Cross landed in that dirt, it caused it to give it a lot of energy, which heated it up, and it transferred into a gas phase, which allowed us to measure it. So when we go back to the moon to verify water, we're going to use a similar technique, yet we're going to use a mass spectrometer. So we will actually drill down in certain locations. We'll drill a meter deep, go down a meter into the dirt, into the surface of the moon, and we'll bring up little I'm going to use an auger. I hope you know what an auger is. An auger is like a drill bit, so you're going to auger down at the surface, and we're going to go up. And when we pull up, a little bit of dirt comes out of the hole, and we're going to capture that dirt, and we're going to drop it onto the surface of the moon, and we're going to watch all of the water sublime, or come out of the water in a measurement as a gas, and then we're able to measure it. So we'll use a mass spectrometer, and we'll measure it down to a meter deep, and we're doing that on a couple of different missions. Actually, we're using a Prime 1 will be the first one to go, and that should be in next calendar year. And then we'll be on the Viper mission, which is a rover mission, and that'll be in calendar year 2024. So I hope you're watching.
So you guys work with robots, like in some capacity? Okay, so that handled about 10 questions in the chat. They want to know if you work with robots. And then a few of the kids wanted to know what implications would that be if they did find water on the moon.
Okay, so I turn that around and ask you guys, why is water important to you? Do you need water to live?
One of the kids messaged for life.
Yeah, you do. You need it for life. You need water to live. So what else can we use water for? Can we use it for fuel?
Yeah, so one kid said for plants to make energy, create energy.
Yeah, we can use it for fuel. So you can separate water and hydrogen and oxygen, and then you can recombine them as propulsion. So you can use hydrogen fuel. You've heard us talk about the recent Artemis mission where we had some slowdowns because we had some leaks in our hydrogen fuel pipe that led to the ground system that we had to fix recently. So we could actually do that on the moon. We could take the water that's on the moon, we could break it apart through a process called electrolysis. That's when you break water into H2, 2 hydrogen atoms and an oxygen atom, and we can separate those two, and then we can use that hydrogen gas either to create a fuel. Either there's multiple types of fuels you can use, but water is really it's something we as humans must have for propulsion and must have for life. And so water means that all of us, all of humanity, has the opportunity to do deeper and more extensive exploration of the solar system. And without that, if we can't find it on an asteroid or on a moon or somewhere in our travels, we can't get it. We can't get it off of the Earth and take enough with us. There were some really famous explorers in America. Lewis and Clark. They started in around St. Louis, which is in the middle of the country of the United States, and they traveled and explored from St. Louis all the way across to California. And they did that by living off the land, right? They didn't put every bit of water and every bit of food in their 1700s, 1800s. They went in the 1800s. They didn't put every bit of food and water on their wagons, their horse-drawn wagons, in order to get from St. Louis, the middle of the United States, to the West Coast. They lived off the land. For us humans now to do deeper exploration into our solar system, we've got to be able to use the resources that are on the moon or on an asteroid or even on Mars in order to enable us to live there and sustain our life, to be able to get to deeper locations in our solar system or to get home. So that's why it's so important to have found water on the moon, and then to understand how we can get access to it and how much we're able to harvest it. The moon is very, very, it's a very difficult place to be because it's in almost a pure vacuum, right? So it's either super hot or super cold and there's no atmosphere. So living and working in that environment is going to be challenging. So back to your robot question or robot comment, we're going to use a lot of robots to enable us to harvest the water, to be able to transform it from water as a frozen ice product into a fuel, for enabling either further exploration, a return to the surface of the moon or the Earth, or for human habitation.
That is an exciting career.
I think it's exciting for you guys who are out there listening, because I mean, you know, if you can look back in your history books, we saw aviation take off, right? Aviation to be able to, all the planes, the Deltas, the TWAs, the Air France, the Lingus Air, the, you know, whatever, all of that came because the industry started small and got bigger, right? Well, we're seeing that with space now. You guys see a lot of the commercial space companies starting up commercial space launches, where we launched people that weren't even, you know, NASA trained astronauts, but they were commercial astronauts, right? We have a whole bunch of new vehicles that we're launching into space, and we've got one at the Space Coast here going up almost every week. Some launch of a satellite or whatever, not humans, but sometimes we send humans up to space station. But what the kids here that are listening are going to get to see in their lifetime is just this access to space that's going to be really, really cool. And it's going to be a reason for you guys to really think about in your careers, going into a career that's going to be part of that space industry, be part of the next exploration process. So if you like science even just a little bit, and like math even just a little bit, push yourself, be part of that new frontier. That's going to be where it's exciting. all things here on Earth, they're going to be, they're going to be here on Earth. Just think about if you could be part of that space. I mean, that's really cool, right?
I think we have a few future explorers on here. We'll go with a few more questions, then we'll let you go. Is that all right?
Sure.
So this
Yeah,
is from
absolutely.
Christelle, and Christelle is, I believe, in France. Christelle, you had a very good question about being a female working at NASA. Go ahead and unmute.
Hey, it's just a dream to meet you. I have a question. Do you know Katherine Johnson, and what do you think about the work of the women in this field? It's difficult.
Okay.
Ralph, I'm going to need you
I
to
got you.
issue
I got
very
you.
light.
She had two questions. She said, have you ever met Katherine Johnson? And then the second one was, what do you think about women's contribution in your field?
I have unfortunately not had the privilege of meeting Miss Johnson, but I do know several of the first, I guess, pioneer women that work for the agency. And I can tell you they're just such great role models. As far as the second question was women's contribution to the agency, I mean, I work for a center director. Her name Janet Petro. She is the head of the Kennedy Space Center. There's a female director at Johnson Space Center as well in Houston. So we have some great role models and contributions to the agency. I'm working on this lunar mission with a scientist that's a PhD analytical chemist that's heading up our science on the mission, who's also a female. Her name is Dr. Janine Captain, and she's really great to work with. I work with several systems engineers. Systems engineers do a little bit all the way around for touch all of the different systems on the payload that we're sending to the moon. And that's another woman that I work with. So it wasn't as prevalent when I first started working for the agency. We didn't have as many women engineers, but we've really, see a lot of women now that are pretty much, in leadership roles as well as our male counterparts. So I've seen a lot of that. As far as contributions, I think from my perspective, one of my contributions to the agency is in my environmental engineering side. I developed several technologies. I have about 13 US patents, and most of them are environmental cleanup technologies. One of them is in radiation, but the others are environmental. And one of them was inducted into the US National Inventors Hall of Fame. So I actually stand alongside of 2 or 3 other NASA people recognized for their contributions to overall invention. Steve Jobs is there in that list of names, as well as, the Ford and Edison, and, there've some people that have really done some contributions to the agency that made not to the agency, but contributions to the US that made a difference. So I look back on my history with the agency as a female, and I think I have no regrets, and it was great. And I feel like I left good footprints behind me.
Heck yeah, you did. From you're in the Hall of Fame for Space and Technology, and you have a number of accolades, a number of awards, and a number of inventions and patents. And again, we can't thank you enough for your time. We'll go with a few more questions, then we'll let you go. This is regarding environmental sciences, and this comes from Maria. Maria, this was an awesome question. Go ahead and unmute to ask Dr. Quinn. Well, I'll ask. Okay, there she goes. Go ahead, Fred. All right. So she wants to know, I'll ask for her, what can the kids do if they want to raise awareness as far as environmental protections, environmental sciences as teenagers? What kind of things can they get involved in?
Oh, okay. So what can you do to raise environmental awareness? I think one of the things people mistake is that they feel like they have to have a huge impact. I think it's okay to start small and to recognize that your community makes a difference, right? So if you are interested, like one of the things that I'm passionate about, I'll tell you this, I'm passionate about getting rid of single-use plastic bags, right? Every time you drink out of a straw, every time you take a plastic bag home from the grocery store, that bag is going to be on this planet for 150 years, unless it's, one that's made of cornstarch or whatever. And so I think if you wanted to make a difference, you could, work with your local community and say, how do I start an awareness? Maybe you want to get a group of kids that go to the grocery store and say, and I think in France, because I think Lisa Maria is from France. Is that right?
Yes.
Ralph? Yeah. So Maria, you probably have a very different situation there. When you go to the grocery store, you probably take a recycle bag with you to go to the grocery store. I know Europe has a much different approach to, single-use plastic bags, but you still use your section of straws, because every time you go to the cafe, you'll drink out of a straw. So maybe you go to your local district and say, how do we begin an effort to get rid of drinking straws, right? That's just an example. It could be you want to work on cleaning up or lowering the pollutants into your rivers from fertilizer, right? So if you're near a river and you want to minimize the fertilizers going into the river, you start at your community level, and what happens is it grows and gets bigger. And so one village in France starts it, and then you meet up with a neighboring village and you say, hey, I'd like to do this, or little city, or whatever, and you just start growing from there. And remember that impacts don't have to be global to be effective. Everything starts small, and you can get bigger from that. So you just have to figure out what areas you're interested in. And I think kids are very well, they're heard. People when a child, especially if you're a parent, I have 2 daughters, right, Maria? So when my kids talk to me and they have a passion about something and they really want put in, I don't know, recycle baskets, or you're trying to address it, your location, then just, go and hear your voice. I think your voice carries a long way. And you say, I'm passionate about this because I want this planet 70 years old looking back in my I want to see how pretty the sky is. Don't want to see soot on all the cathedrals, or the bridges or whatever. So that would be my advice.
That's wonderful, wonderful advice. So before we let you go, because we don't want to keep you too long, I usually end these with this. I know we're having kind of some network issues.
Yeah, there we go.
Are we good? Okay. What kind of advice would you have for these kids as they go off into the world and figure out what they want to do? What kind of careers they want to pursue? As someone who's a leader in your field, what kind of advice can you impart on them?
Okay, so I think one thing that's really, really important to do is to remember that when you go to school, it teaches you the art of learning, all right? You're not going to use everything you study in your job, but you are going to learn how to learn. I came to work here with an undergraduate degree in engineering, and I had learned a whole bunch of formulas and a whole bunch of execution styles of math and science and English and history and communications. It's all in there. Typing, take a typing class. It's all part of it. But don't expect that when you get to the work that you have to stay in that degree. Let's say you choose that you're going to go to college and you're going to choose a science major or math major. I'm kind of really pushing that because I really want you all to be future frontier people, right? To go out deep and to explore the frontier, the space frontier. So if you're going to go into math and science, and even if you don't go into math and science, we take all the degrees to enable it. There's the business end of it, not as much, but we do have the business side, and we have like our public affairs people that work on, they worked a lot with Ralph and myself to get this organized for today. But whatever you study, remember that what you've learned in class is taught you how to learn, and you're going to continue to learn even when you come into work, and you're not expected to know everything. There are things that you will have been exposed to in your class that you'll kind of go, oh, I remember a little bit of that, but I may have forgotten 99% of it. But the fact that you've learned it one time allows you to come back and learn it over again. I think it's really important to know that no career you pick, other than maybe medicine, is there's the opportunity to do a variety of work, even with one degree, right? Meaning, if you look at my career, I started out in doing shuttle engineering. Then I moved to civil engineering, designing roads. I mean, I designed a road. Concrete asphalt design has nothing to do with shuttle design, right? And shuttle testing. But the fact that I was an engineer in that field and I had the resources to do it meant I could try something different. And I think people think that they have to know what they want to do as soon as they start to go to college. I think you need to know that you want to try engineering, and then if you don't like it, you can move away from it. If you're good in science or math, you know, physics, material science, chemistry, those are all great degrees to go into. But just realize that you're not stuck in a box. Even if you get a degree, you can actually expand that degree, the knowledge you learn from that degree, and apply it to different areas. And I've done that throughout my whole 33 years. So I think that's one of the best advices that I'd get, a piece of advice I'd give. I'd also say that when you're picking a college, take time to do research your first 4 years, right? Whatever university you're at. If you're in a US university, a France university, you know, Brazil, Ecuador, I don't know where everybody's from, but wherever you're from, do research as early as you can. When you choose to go to a different college, or even in your high school career, ask them up front, how do you get engaged in research? Because once you're out of the classroom and you're into the application side, oh, it gives you lots of energy, and it makes you excited, and it makes you want to feel part of something, and it makes you want to keep doing it. If all you're doing is reading and writing and doing tests and not really applying it, it's really hard to make the connection. So the sooner you can jump into the research side, and you're not going to get paid for this, you are getting a gift to get in with a college professor to help them. Even if all you're doing is cleaning up their notes, you're gaining some knowledge from it. So when you decide to go on to college, and I do hope you will, and you decide to go into engineering and sciences, which I do hope you will, but if you don't, I mean, that's okay. You can still do research in that area and make it a qualifying point. I choose this university because, right? And that's really, really important, because it'll help you. Engineering's hard. It's hard. It's a hard degree. So you may have the smarts to do it, but you got to have the grit. And the only way to stay in it and keep that grit is to become engaged in research during your college years. And it also makes you more attractive for getting hired, right? So if you want to get hired later on, you got two people, one's only got an A, got all A's, but never applied it. And you've got a person who's got a B and has applied it. You're most likely going to say, that person knows a little bit about how to apply it, and I might choose that person over a solid A with no experience. So that would be something I'd have everybody walk away with.
That is some solid, rock solid advice. So we can't thank you enough, Dr. Quinn, for spending time with us today. Guys, this recording will be available once we get this footage processed and approved. So thank you all for joining us. And I'm going to allow everyone to unmute, and then I'm going to allow everyone to say thank you, and then we'll end the meeting for all. Can we say thank you, Dr. Quinn, for taking time to share with us?
Thank you.
Thank you.